being here. I'm glad to see that there's some interest in this because it definitely wasn't on my radar when I was a student. And so it's good to see that it's become more popular, and that's also getting a little bit of recognition among students. I think it's a really important skill for people to have in the back of their minds. I've got my email address down here on the bottom in case anyone wants to write it down, but I can also get Dalton to message it to you afterwards in case you have any follow-up questions. To give you guys a quick idea of what we'll go over today, I wanted to give you a brief background to myself and how I learned GIS, go over what a GIS is in the first place, who uses it in a job, and then how you guys can use it. So we'll go over a quick demo, and I'll give some resources of where you can find data, which software is useful to download, and how you can get started. I also hope you know that if you have any questions, you can always put them in the chat, and I'll try to look at it periodically so I can address whatever it is you're wondering. Make sure to weave those in. So a quick introduction to me. I went to Davidson, as Dalton said. I graduated in 2017, so I've been out in the professional world for 3 going on 4 years. Here are a couple of icons to give information about myself. I was a classics and German double major, which, if you're wondering that it's not a practical combo, you're definitely right. So it took a little bit of maneuvering outside of school to figure out what I wanted to do, but ultimately I've landed at the National Renewable Energy Corporation, which is a Charlotte-based utility scale solar developer. So I've got a picture of one of the projects we've actually built here. And in this role, I use GIS daily, oftentimes for 5 or 6 hours a day, and I've learned it all outside of school through resources like Coursera or through my coworkers, just using it in the day-to-day. And so it's definitely an option for you guys if you don't have like a technical background. A lot of it's very intuitive and also just has to do with trial and error. So to talk about what a GIS is, a lot of people think that it's a map. And while I love maps and they're great, it's a lot more complicated and also a lot more descriptive than a map. So if we're looking at something like this, there's only so much that can be offered here in terms of data and information. And it's really not that intuitive. So you can't ask this map to answer any of your questions. Like if you want to know where the Sargasso Sea is, it's going to take you a long time to comb over every single piece of the grid and locate that. And then when you do find it, it may not even necessarily have the name for it. And so in the 60s and 70s, people developed these geographic information systems to be able to store data into a map. And if we're thinking about a traditional data table, like the one that we're looking at, this is the back end of every geographic information system. So this, I'm sure, looks like a lot of nonsense to you. And I think all of us would prefer to see this in another way because this is very difficult for us to digest and get any sort of idea from. So what we're looking at here is zip codes on the far left. And then we're looking at the average watts of solar energy that hit the Earth per month at each of these zip codes. And so I think unless you're a cyborg, this probably doesn't mean much to you. But if we have a GIS that can process all this information, it becomes very easily digestible. It becomes very useful to us. And so this is a map that I made using that data table, which had like 80,000 rows or something. And we can see here in a half of a second that we're getting the most solar energy out here in the Southwest, and we're seeing much less in the Northwest and around the Great Lakes. And so that's just one use of them. And today we'll go over how you can actually make a map that looks like this in fewer than 5 or 10 minutes. And so the ultimate value of a GIS is that it's a map coupled with data, which allows you to ask questions of the map. And so some of the sorts of questions you could ask of a GIS, and these are questions that are used in everyday planning by a lot of corporations. So whether it be a franchising corporation, whether it be like a human rights organization, these are always brought up, and a lot of times they will consult GIS specialists for it. So one example I've got here is, where is the best place for the newest Taco Bell? Why is this not a good location for an elementary school? And becoming even more profound or more research-based, are lower income families affected more harshly by natural disaster? And so if you've got the right tools and if you know how to put the data together, these are questions that you can pose to a well-formatted map and be able to get an answer for. So most importantly, and what you guys are here for, is how can I use a GIS? There are a couple of different ways. I'll give you a very short intro into how the data is stored in a GIS, and then I'll actually take you over to QGIS to see the platform. But basically there are two types of layers. There's a raster layer, which you can think of as a satellite image. It's any kind of continuous picture of an area. And then there's vector layers. So these two on the bottom are a raster, the two on the top are a vector. The vector layers are really the ones that save the data that you need. So coordinates of some place, you can have other figures such as the population density or the location of certain types of features, but those are the core components. And just to draw very quickly into the differences between the two, the reason we most often use vector is just because these data models are much smaller. So if you're looking at the amount of detail on the left of this island, you can see that it's much, much lower than the very vast detail we have in the image of the right. And so this is topography. But that's always interesting to know, I think, when you're first starting out and looking at data sets, and you'll see that they're stored sometimes as vector, sometimes as raster. Okay, and now to show you guys how you can actually use these, I'll take you over to QGIS. So you guys should be able to see a blank screen here. This is the landing page when you open QGIS, and I'll also send along the link so that you can download this to your own computer. It's all free. Most of the tools are open source, and so it's a great option for students because you can really play around with it with basically no repercussions. And so to give you a little bit of a tour, when you land, you'll see that on the top you've got all these different options for manipulating a map, and over here you have a section called layers. This is on your bottom left-hand corner. And so that's where you'll actually see the data displayed. And so if we want to just get a base map, so a raster layer and a satellite image, we're going to go up to our top bar and go all the way to the right to web. We'll go to our quick map services. I'm just going to search here. So this is a repository that saves a lot of different satellite imagery. And so you can choose whatever's best for your project. Most often, it's going to be a Google or Bing option, but it's also got a lot of kind of more niche options. So if you're looking more for ocean data, there's some options from NOAA, there are some from different defense organizations, but for now, I'm going to scroll down, and there, as you're seeing, are a lot of different options. These colors next to the add button, they indicate how often it works. So if it's a yellow, it means it works about half the time. If it's red, it means it probably doesn't work. You guys can see that these names are maybe a little bit off. So like this one doesn't have a space. This one is not even provided by Google. These are probably ones that have been self-made and aren't actually made by the company itself. And so I'm going to go over here and grab Google Satellite, which should be around. So we'll grab this one, and it should work. And that's exactly what we were expecting to happen. We see that the raster layer pops up over here on our bottom hand corner in our layers section. And so if we want to zoom in, we can grab our magnifying glass up here in the left-hand corner, and zoom in, and we've got the United States. It's nicely labeled. If you want an option that's not labeled, that's available as well. But there's not a whole lot we can do with this yet because we don't actually have any data. And so if we want to be able to look at something, be able to have something to talk about, then we can start adding layers. And so the way that we'll do that is we'll go up to our layer toolbar. We're going to drop down to the third option, which is add layer. And we're going to go to add vector layer. So you guys will remember that we spoke earlier about vector layers versus raster layers. If you're just starting out, pretty exclusively, you'll be working with vectors. So it'll bring up this pop-up. You have a few different options here as well. A file is what you'll use if you have a shape file, which is the most common. Sometimes you'll get a directory if it's a geodatabase, but for the most part, file is normally where you want to be when you're trying to upload. And so you can leave the encoding as is, but when you're going to source, you'll just search on your computer wherever you found the data. So I downloaded this data from the Energy Institute of America, and I'll link that to you guys so that you can look it up yourselves and be able to play with it. But you'll see that each of these, what is this, 6, I believe, they all have different file endings. So they're different types of files, but they have the same prefix on the front. And it's because you need all of them to be able to create the layer. But the one that we're actually going to upload is the shape file. So you can see on the back end, it's got .shp. So we'll just open that up. We'll add it. And ta-da, we've got all of this data. It's pre-populated into the US because it knows exactly where it needs to go. It's geospatially referenced. But again, not that useful because it's not formatted correctly. So if we go in and zoom in, we see that they're all exactly the same color, even though they have different values. And I can show you that by clicking on the layer itself, going up here to our little clicking guy and the big I. And if we click on one of these tabs, we'll see, okay, so it knows it's in Iowa, and it's got all of these values for how much solar energy reaches each of them. But then if we click down here, we see that it knows this one's Missouri, and it's got totally different features. But they're showing up as the same color, and that's because they don't have any sort of properties built into it. And so the very first thing that can make or break a map is the actual display of it. And so to fix that, we're going to go over to the bottom left-hand corner. We're going to double click. You've got a lot of options here. So if we open that attribute table, you guys will see what we had open earlier, which I showed you in the Google Slides. But what we're interested in now is going to the properties. So that's the very last option. We're going to open that up. And you can see that right now it's got the default symbology, which is a single symbol. So regardless of the values that are stored in that data table, it's representing each space exactly the same way, which is not very helpful for us. So what we can do, there are a couple of different things. You could make a categorized symbology. And so you could say, all right, for each of these states, I want you to make a new color. And so, for each of these states, make it a new color, and we'll see what that looks like. We're seeing that this is all black, and the reason for that is that it's got a outline on each of the squares. So the way that I've come to fix that is by clicking on the symbol and then looking at the simple fill and seeing that the stroke color is black. So we're going to change that to transparent stroke. We're just going to apply that again to see what that looks like. So now using the categorize feature, we're seeing each of these states represented in a different color. Again, not super helpful, so we're going to go over to graduated, which is the fourth option in that list. We're just going to choose the attribute that is best at representing each of these cubes. And so for us, that's going to be the A and N DNI, which is the actual solar resource. You guys might recognize these as the column names for each of those columns in the attribute table, which I just showed you. And so we're going to go ahead. We have to make a few decisions here. So first, we're going to go back to this symbol, make sure it's not got any stroke fill. That's good. And then we've got a legend format, which is fine. Precision 4, we're talking about how many figures after the decimal we're going to follow. And then after that, it trims it so we don't have super long values. And then we've also got a color ramp. So this is important if you're going to be sending your data externally, because you want to make sure that other people can understand it. The one that I think is really useful when you're talking about temperature is spectral, because you're seeing that you've got this expands from blue, which we associate with cold colors, all the way up to red, which we obviously associate with really warm colors. And then we have a few other decisions. So where we have the classes, this is going to come up with all of the different breaks that you could have in your data. So you can think of this as just the color scale. So blue might be 0, red might be 100. But there are a lot of different ways that we can try to break up the data so that we're getting a more honest idea of how that data is broken down. So if we do equal count in quantile, then we hit classify down here. We're going to see it's only going to use 5 different colors, and it's going to break up the states and the different squares into those colors. That maybe is not a good way of doing it, because we see that there are huge differences in the actual values, which are all being represented by the same color. So getting 8.8 of the watts per meter squared is actually very different than 6.2. And so it's normally a better option to go through and make sure you have more colors broken up here. So we'll hit apply again. And now you see we have way more classifications down here. And so we're getting a little bit more honest of the representation of these values. And the last thing I would do, and this is being a little pedantic, is I would invert this color scheme. Because as we're seeing it now, it looks off of the bat as if the Midwest is getting the most sun in the country. I think if you're from Ohio, you probably know it's probably not accurate. And so I'm going to go back over to the color ramp and select this invert color ramp. I'm going to go back down here and hit apply. Okay, and so now we have a nice picture of the US, and you can see all of the average solar that's hitting the states. And so now all of a sudden we've got this data that is at our disposal and that we can actually use. Another great thing about the GIS is that you can filter it super easily. So if you're only interested in, let's say, 1 or 2 states, you can always right-click again on the data, on your data layer, and go up to filter. And if you've ever used SQL before, the standard query language, this will look really familiar to you. This is the standard that they use as well in a GIS. And so you'll just scroll down. Again, you've got all of your fields here, which are all the column names. And so just decide which you want to filter on. So I'm going to double click state name. It automatically goes through and formats it with quotation marks, which I need. And then you can hit sample, and it'll give you a sample of some of the values saved in that column. And so if we only want to know what the solar is looking like in Alabama and Arizona, we can click in. And then we're going to put a parenthesis, Alabama, comma, Arizona. And if SQL is very new to you, all of these are really available on the internet. You can always just Google and describe what it is you're hoping to do, and there'll be 1,000,001 resources to help you with it. And so we'll go through and we'll test it. So there are 4,300 squares that match that, and boom, we've got our 2 states isolated. Okay, so I think we're at 4:25. I want to open it up for questions, especially while I've got the QGIS open here. So I'll open up the chat, or feel free to go off of mute so we can talk. Zane?
Yeah, so if you have like raw data files with like say GPS coordinates and some other attribute that you're measuring, how would you create those 6 file types?
So if you've only got the coordinates, then you might manually have to go in, unless you can format it in exactly the way that it would need it. So that would mean in seconds, minutes, degrees. And so there are a lot of resources online that can help you do it. But the easiest way would be to split out the coordinates into 2 different columns. And then you could go through and try to use, I know there's a tool for it, where they'll go in and it'll create a point at each of those coordinates that you've given.
I was wondering what the difference between QGIS and ArcGIS is. ArcGIS is what we usually use at Davidson. I didn't even know this one was a free download, so that's interesting. I guess it might just be the company, but if there's, it seems like it's pretty similar, but I wanted to get your thoughts on that.
So QGIS is really great if you are using your own data. So it's obviously free, as you mentioned, and it's a little bit more industry-wide friendly. As you're saying, more people are able to use it. It's more accessible because of the price point. But ArcGIS is really great because they've gone out and actually stored and captured data on their own time. And so it's awesome for students, it's awesome for researchers, because you don't have to spend all the time searching the census on the US websites and trying to find whatever data set and formatting yourself. ArcGIS has already done a lot of that legwork for you. But I would say in most professional settings, QGIS is probably the standard.
Gotcha, thank you.
Sam?
Yeah, how did you like get started with this? Or like, what was, like when you came out of college, what was your interest?
Yeah, that's a really good question. So I'd done an archaeological dig while I was in school, and I worked with a lot of people who are using the GISs to do what I thought was really amazing. They were using satellite imagery to try to identify graves from above. And so that was my original interest. I don't do that in my day-to-day now, but I had a little bit of exposure to it when I was applying to jobs. And so I started talking to the solar company about it, and they said, this is actually a skill set that is really valuable to us, and we hope that you would also spend more time investing in learning it. And so I did one course with the University of Toronto, just online, learning about the specialization. And so that was my main entree into it. And then just from being online and having to use it in my day-to-day, I've gotten really familiar with it and been able to make a lot of progress. I think one of the benefits of GIS is that there aren't that many programs in universities and colleges yet. And so pretty much everyone who's using it is learning online and also creating resources and allowing others to use those and lean on them as well.
Cool.
But if there are no other questions, I would love to give some of these resources over to Dalton so you guys could potentially learn on your own. And I hope you also feel comfortable reaching out to me if you have any questions. I'm always happy to help or try to give any sort of advice that may be helpful.
For sure, if you will send those over to me, I'm more than happy to forward that up to you all. I had a quick question. Have you used any of the different learning paths that are in LinkedIn Learning to sort of build upon your knowledge of GIS?
No, I haven't. But are those paid or are those free for everyone?
It's free for Davidson students. I didn't know if you used any of those when you were at Davidson or not. It used to be, so if you graduated in 2017, it was probably lynda.com then, transitioned to LinkedIn Learning now.
Yeah, no, I haven't yet, but I think they're probably all good options. And one of the nice things about it as well is that there really are only the two platforms, and they are pretty similar. So if you study on one, be it ArcGIS or Q, you can always use the other one. So I would recommend any of them.
Perfect. All right, well, that wraps everything up